Hi, I'm Jody and let's continue LPIC1 021, the second part. In the first part, I showed you one of the most important things on a Linux system, which was FHS, File System Hierarchy Standard, which lets you find your way in any Unix system you stumble upon. But in this part, I'm going to speak about partitions. If you are familiar with Windows, you know about drive C, drive D, drive E, and others. In a Windows world, if I have a disk and if I partition it in three different parts, as you know, when you are partitioning a disk, when you have a disk like this is a 1 terabyte disk. So when I buy it, it's a 1 terabyte of disk space. If I want to use it, I have to partition it. I have to create parts on it. If I create 3 parts, for example, 500, 300, and 200, in a Windows world, this would be drive C, drive D, and drive E. In this Windows world, if I add one USB disk to my computer, if I connect the USB disk and then connect the CD drive and then connect the network drive to my computer, this will be, for example, F. This might become G and this might become Z or whatever. These are different disks you see on the Windows machines. But on Linux, as I said in the previous section, everything goes under one root directory, just like a tree and its branches. If you remember, we had some /media, we had a /mnt. So if on the same computer I install Linux and I have my file system here in one partition, if I connect a USB disk to this, USB disk might go under /media/Jody. And then when you enter this directory, write something, read something, practically you are reading and writing files from here. If you connect a CD drive, it may become /media CD-ROM. Depends on your the distribution you are using. This might become this might go under /ron or any other place. But this way, if it's mounted automatically here, when you go to /media CD-ROM, you are working with this. And if I want to add a network disk to my computer, I can issue a command like mount. As you know better than me, mount is something like this, mounting something. If I mount this drive, whatever the address is, on mnt net, and before that I have to create a directory here. If I press enter and everything is okay, if I go to this path mnt net, I can see whatever is here, write on it, read from it, or whatever. This is how Linux works. So what happens if you partition your disks? If I buy a desktop computer with a 1 terabyte of disk, I may partition it as, for example, /boot and 1 gigabyte and that would be 999 gigabytes. This way, everything will be installed here unless /boot, because /boot resists on another partition. So whatever you write into the /boot will go into the other partition. You can do the same thing. You can say, I have one disk, this is /boot, this is / and this is /home. For example, 1 gigabyte for this, 30 gigabytes for this, and 69 gigabytes for /home. This way, when you install your Linux, if you use the partitions like this, everything will be installed here, except /boot, which will be installed here, and slash home, whoever, for example, the slash home Jody, if you create a directory here, that will go to this partition. Why we use this? There are different reasons. One is separation of the security environment. This way, if something strange happens to this partition and this partition is completely dead, your system will still boot because it's booting from here. If you need encryption on your whole system, you can encrypt this and this, but for sure you cannot encrypt slash boot because when computer comes up, it needs to be able to read the kernel. So if it's encrypted, it won't. So separating slash boot will solve this problem. You can have an unencrypted slash boot and an encrypted slash. Or for example, if you want to have a huge disk for your users, you can say, I have a server with only 1 terabyte of hard disk only. I will give 1 terabyte to slash boot. I will create another partition here. So I will create 2 partitions on this disk, and the other one will be 991. I will use this 4 slash, and then I will add a 5 terabyte disk partitions as one partition, and I will mount this under slash home. So all the users data will go into this disk and this partition. All the system files will be here except the booting data. This is how you use your partitions under Linux. We will have a separate module for partitioning, a separate module for formatting disks, a separate module for mounting disks. So don't be afraid if you didn't get all I said. This is just an intro. You should know that under old BIOS systems, we used to have one MBR, which was a place that system needed to be booted from. And in the BIOS systems, we only were able to have 4 primary partitions per disk. So if you were partitioning your disk, you were able to create only 4. The first hard disk is /dev SDA. The second hard disk is /dev SDB, and so on. The first partition of the first disk will be SDA1, SDA2, SDA3, SDA4. In some cases, we needed more than 4 partitions. There used to be a trick. It still works. On a BIOS system, you were able to partition your disk into partition 1, partition 2, partition 3, and then create a extended partition. In this extended partition, you were able to create more logical partitions. This was a way if you needed more than 4 partitions on a BIOS system. On the new UEFI systems, it uses GPT, and you are able to create 128 partitions, which looks enough in the near future. So, what we covered. If you have a physical hard disk and you want to use it, you have to create partitions in it. You can create different partitions, and under Linux, you can mount them in different places. This can hold all the system except /boot. We will speak a little bit more about this, but let's have a look at a couple of commands. Hey. So let's run our terminal. Let's become root. Then I can use something like Fdisk, which is the most famous tool everyone on the command line uses to, not everyone, some people use, one of the tools people use for partitioning disks. So I can say, check this one. It says, okay, what command you need? See, M is for help, a little bit strange. H should be for help, but M is the menu. I can see this. We will work with this later, but at the moment we will use the P option. It will show us, it prints the partitions. As you can see, /dev SDA1, it's a boot partition, it's a BIOS system, 1 GB, its type is Linux, and I have another partition, SDA2, which is 15 GB, and partition is Linux. If you want to see how this is mounted, you can issue the mount command. This will have lots and lots of lines. So on a newer system, there are lots of different things going on here. But as you can see, /dev SDA2 is mounted on the root system. So everything goes here unless we mention something extra like this. /dev SDA is used for boot. As you can see, I have 2 partitions. One is 1 GB used for boot, and another one 15 GB used for root. So everything will go here except boot files. As I already said, this is important. It separates partitions, so I can, for example, do encryption here, but system will be able to boot. /boot needs to be readable by your boot system, by BIOS or UEFI. So it cannot be on a network, it cannot have a strange file system, and it cannot be encrypted. But so we separate them. Safer and cleaner. Another command is what we have here, maybe parted. Yes, we have parted. So I can say parted /dev SDA print the status. Same data. It says you have 1 disk. This is the total size of this specific disk. And these are the... why this happens, I don't know. And these are the sizes. This is the end. This is the size. And the other one is 1 GB. And it boots from here. And we also had the Gparted. Gparted is a graphical tool. Graphical parted. Maybe parted or Gparted is not installed on your system. You have to install them yourself from add remove program or whatever you have. We will cover this later. Gparted is very useful. It will show you graphically what you have. Also, you have a list here. You can unmount it if needed. You can resize it if it's not mounted, and it will give you some more control. See, you can even have the resize. You can make it a little bit smaller. So I can create another partition here and some basic management. If you need more management, Linux Word gives you the LVM possibility. LVM is logical volume management. What's the idea? At the moment you have a hardware, which is your physical disk, and you partition it in different parts, right? But what happens is I only have hardware this big, for example 2 TB, and I want to create a partition which is 3 TB. Impossible, because you cannot span your partition on another hard disk. LVM lets you do this. LVM is covered in LPIC1, I believe, but here you only need to know the basics and be aware about its existence. What LVM does? LVM gives you the logic of physical volumes, a whole drive or partition. So if you have one disk which is 2 TB, this can be one of your physical volumes. You have another disk which is 1 TB. You create one, for example, 500 GB here, another 500 GB here. Later you buy another 2 TB, whatever disk you have. These are your PVs, physical volumes. You can add all of these in a large VG, which is volume group. Now I have one huge 2 plus 1 plus 2, 5 terabyte volume group. Now I can start creating my logical volumes here. For example, the 3 gigabyte one you wanted, you can create one 3 gigabyte. This way you can create partitions even larger than what you have. Even better, after some time you create one 3, one 2 gigabytes. After some time this is not enough. Because you are on LVM, you can just buy another 2 terabyte hard disk, format it, add it to your volume group directly with one command. So your volume group will be larger. Now your volume group has free space. So you just tell it, increase the size of that 3 to 5. It will use this part and will add it to this, and this will be 5. This is why LVM lets you manipulate your disks very, very, very easy. On most systems, they're already installed. So if I do, for example, LV and double tap, it will show me all logical volume commands I have. Same with PV, all physical volume. For example, scan for them, change one of them, create one, display them. On logical volumes, scan them, resize them, remove them, and all the other things. You don't need to know the details, but it's cool to know that it's there if you ever need it. On the servers, most of the time you see that they are using LVMs instead of direct partitioning. On the last part of this section, you have to have an understanding of the swap. Be with me. Swap was one of the very, very cool ideas in the Unix world. One of the things that made whoever technical person, no non-technical person, I believe, never seen Linux on the first years. Oh, anyway, whoever saw Linux to say, wow, what swap does. Think about your computer. You have RAM. And for example, you have 4 gigabytes of RAM. But you have a program which needs 6 gigabytes. On a conventional system, this should give you an huge error and say you don't have enough RAM to run this. Or think about this scenario. You have 4 gigabytes of RAM and you have lots of programs running and your RAM is exhausted and 3.9 is full. Now you want to open another program which needs 500 megabytes of RAM. Practically, you should not be able to do this unless your operating system will knows how to write, for example, 1 gigabyte of this RAM into a disk. Then it will have enough empty place. It will give you 500 you want. As soon as the program who was using this RAM needs it, the computer, operating system technically, will read this RAM from the disk and will give it to the program and write some other things which are not being used at the moment to the disk, using your disk as the RAM. Or in this case, if you only have 4 gigabytes of RAM and a program requests 6 gigabytes, your computer might be able to create a 2 gigabyte file on a disk, use it as a RAM, and will tell you that now you have 6 gigabytes of RAM. So technically, you cannot download more RAM from the internet, but you can use your disks as RAM. It is slow. It is not a solution for a system which doesn't have enough RAM. It's useful during specific peaks to prevent your computer from crashing and these kind of stuff. Here, I told you it can use the system. This can be a file, but most of the times, swap is a separated partition. This is called swapping file systems or paging. One page will go to the disk, the page will be read back. So most of the time when you create a partitioning for your computer, you give some space for the boot. So computer will boot from here. This is readable for the PC, whatever you are using, BIOS or UEFI can boot your computer from here. It's not on the network. It's not encrypted. It doesn't have a specific file system, normal file systems. Then you will have a swap partition In Linux, the format of this is called swap, and then you have whatever partition you need. For example, on a desktop, you may have only a slash. Everything goes here. What should be the size of your swap? This is very controversial. There is no correct answer. In older times, when the hards were slow, they used to say your RAM multiplied by 2, but no more than 8 gigabytes. So if I had 2 gigabytes of RAM, I would put 4 gigabytes of swap. But if I had 6, I would put 8. If I had 16, I would put 8. Nowadays, SSDs are much faster, and RAM is kind of cheaper. So it's easy to have a laptop with 8 gigabytes or 16, or a server with 128 gigabytes of RAM. You don't need to swap that much. And if a computer is using disk as RAM, something is problematic. You have to solve your program. You have to fix your program. You have to buy more RAM. This is not a solution for a system without enough RAM, because at the end, even if you are using SSD, it is slow. Nowadays, they say use your RAM plus 2 or plus 4 as your swap space, because when you hibernate your computer, your operating system will write all the RAM into the swap and then halt itself. When back, it will read from swap, will put whatever is there into the RAM, and then computer will boot up. This is why they say at least use RAM plus a small number, like 2 or 4 gigabytes, so you have a little bit more, and not use double the RAM. Because nowadays we have huge RAMs, and if you really, your program, for example, if you have 16 gigabytes and your program needs to write 32 gigabytes to the hard and read from it, that would be super slow. So older times it was RAM multiplied by 2, but not more than 8 gigabytes. Nowadays they say RAM plus 2 or 4. Again, it depends on your situation. If you have a desktop computer, let's check 3 use cases. If you have a desktop computer, as I said, it's good to have a separated /boot. On BIOS systems, we even had systems with 100 megabytes for boot. Nowadays, they put 1 gigabyte. You can have a swap, as I said, twice your RAM, RAM plus 2, RAM plus 4, and everything else will go into the root partition. If you have a network workstation, a lot of people need to connect to the system, copy their files, do SSH, FTP, store their and whatever. So how you should create this one? If I was the admin and I had for example, 2 terabyte server, again, I will put 1 gigabyte for boot. If it had 16 gigabyte of RAM, I would put, for example, 20 gigabytes as swap. I will put maybe 50 gigabyte as slash, so all the Linux installations would go here, and I would put 20, 50, for example, 1.970, whatever remaining terabytes as /home. So users' files will go here. If some user would copy lots of files on your system, it won't break your root file system. Everything would work. And for sure, using LVM would be great, so you were able to expand this if needed. And if I had a server, which was my own server, nobody else using it, nobody copies new files there, nobody uses it as storage, I would do like this. I would again 1 gigabyte for /boot, so the system will boot securely, safely. Then I would put maybe 50 gigabytes for whatever file the system needed to be installed. And I would put, for example, 1 terabyte for /var, because all my data would go here. My logs, system is working. This may work for 5 years without me attending to it anymore, and it was creating logs, and this may get full. I didn't want this to be affected by this /var. Again, if you had a third-party program running, maybe you could have a separated partition for your OPT or whatever. And again, LVM would be great. It is good to know the RAID too. RAID is a module for itself, I believe, in LPIC1, but having a general idea helps. RAID is kind of adding disks to each other. If you have a server and you have a 1 terabyte disk here, you can add another 1 terabyte disk here and RAID these two hearts to each other. We have different RAIDs. What I'm saying is kind of a failover scenario. In this style, if you have a partition here, there will be a partition here. If there is another partition here, there will be a partition here. Whatever is written here will be written here. Whatever is written here will be written here. So this is a copy. If for some reason this fails, this explodes, breaks, whatever, this will take over. You won't even understand, and your OS won't even understand. This is good thing about the RAID. You will just have a blinking red light, not that red light, a blinking red light on your server telling you one of the RAID disks failed. I need a new disk. You will take this out. You will put a new disk here. It will automatically mirror this one. We have different RAIDs. This is the RAID for high availability. You can have RAIDs which add disks to each other, different levels, whatever, but have a general understanding that most servers do have these kind of RAID disks. They can be on the hardware level, so the firmware on your motherboard manages it, or it can be on the software level and you have a software RAID. Anyway, hope you enjoyed it. Don't be afraid. We will cover mounts, we will cover partitioning, we will cover formatting and everything later in other modules. But now you should have a good understanding mainly from the file system and the logic of the partitions and how Linux mounts them under its tree. Have fun. This was Jody, and we will continue LPIC2. Please subscribe, tell your friends. That will give me courage to continue, and hope and other good things.